Good evening, students. Welcome you back for another important lecture on work and energy. I must
Hello, sir.
congratulate, I must congratulate you, students, for your great performance in the quiz examinations, which you are continuously giving. Getting 100 out of 100 marks is a great credit, which shows that you are learning a lot and you have a lot of interest in science, students. And today we are going to be interacting with you, talking with you, and asking you a lot of important points because today's topic is very, very important. And I am talking of work and energy. Work and energy, students. First of all, I will begin this by asking you one question, student. One question I put up before you. I say, student, do you do any work every day? Tell me. Are you doing any work every day? Any work? What work you are doing every day? Tell me. Tell me, students. Anya, tell me, what are you doing every day? What are you doing? What work you are doing? Are you doing any work at home? At home, students, are you doing any work or you are sleeping? You are not sleeping the whole day. Then what you are doing? Tell me.
So studying,
Okay, let me say, okay,
going on a walk.
you are studying. Studies. All students are doing studies. Okay, then second thing, you are going for a walk. Going for a walk. Anything else you are doing, students? What else you are doing? What else you're doing? Are you doing some work in the kitchen? Some, if you are not doing, your mothers are doing some work in the kitchen, student. In the kitchen, what is being done in the kitchen? Food is being cooked. Okay, food is being cooked in the kitchen. And then what else type of work you are doing? You are even eating the food. Eating the food. Then some machines are also working at your home. In your home, there are machines working. What machines are working at your home? Can you tell me? You have a washing machine. You are using something like bicycle, students, or you are using some car, some mixie, grinders. Something is going on all the time. You got so many things are happening around you. What else we are doing? What I want to tell you that all of us are doing some work. All of us are doing some work, student. All of us are doing some type of work. Doing, I'm saying some kind of work. At home, at office. Presently, I am taking a class. I am in the classroom, student. You are studying and teachers are teaching. Everywhere, in order to live, student, can I live without a work? The answer is no. To live, everyone is to do some work, students, because you need food. What is fuel? Fuel is fuel for the body, students. And machines need fuel. All machines, how will they work? They need fuels. What type of fuels, what type of energy you are supplying, electrical energy, somewhere electricity is being used. In the car, you are putting petrol, student, which is a fuel. So your petrol is acting as a fuel to run the cars. Any engine, student, which is working, that is working somewhere. Work. We are. I want to expose to you that there is so much type of work we are doing. But what is the work which we are talking in science, students? Does all everything looks like work? Yes, of course, everything is a work. When I have studies, my mental attention pressure. Oh, I am working. I am working. What I am working? Studying the books. I am working. I am teaching you. I am sitting here and teaching you, students. Sitting and teaching. Am I doing work? And you see that what happens when you go to the railway stations, there are coolies. They put a baggage on their head and they are moving. They are moving, helping you to go to your coach and put the luggage there. The question is it some type of work we are doing? I said, okay, there is a football player, kicks the football, it goes and goes to some other point. If some work has been done, okay, I said, this is a wall, this is the wall of your home. You push the wall. Does the wall move? Tell me, if you are pushing the wall, is the wall moving? The wall is moving?
No, sir.
No, sir. You have applied some force, that is very clear. But the wall has not moved. Wall has not moved, students. Now the question is, we are saying some work is being done, but here I have told you different type of works. And when I am talking of science, when I am talking of physics, what do you mean by work, student? We are in science, students, we say that work is done when a force is applied and body starts moving. Force is applied and there is a motion in the body. This is a very important point. Unless there is a force, there will be no work. But how do you do work, students? Unless I have energy, I cannot do work. Interesting thing. What I am trying to say, students, what I am trying to say that unless you apply a force, students, unless force is applied, there can be no motion or movement of the body. Movement of the body. And I would say that if there is no, if force is not applied, then nothing happens. We have studied what we have studied earlier. You have studied motion. You have studied the Newton's law of motion, students. You have also studied gravitation with me, where we have given you lectures on gravitation. The question before us is different type of works are being done. Here I am sitting on my chair and teaching you students, lecturing you. You are also listening to my lecture. But are you moving? Am I applying a force to you? Is any force is acting on you? Is your chair moving? The answer is no.
No, sir.
Therefore, I would say that from the science point of view, there is no work done on you. There is no work has been done on you. While I am teaching, I am saying I am doing a work because I am teaching. I am applying my mind. I am writing with a pen. I am writing with a pencil. But students, in physics terms, I am not moving. There is no displacement. Therefore, I would say that there is no work which is done on me or by me while I am sitting on this chair. So, what we are saying in physics, Work will be done only when force is applied and motion is produced in the body. Motion means there is a displacement in the body, students. So force and displacement, that means you are pushing the wall. I am saying pushing the wall. Nothing is happening. Wall is not moving. I am applying the force. I say I'm doing some work, but wall is not moving. So, from physics point of view, from our definition of science of work, which we are talking, the work done is zero on the wall. No work has been done on the wall because wall is stationary. It is not moving, students. It is not moving. There is no displacement produced in the body. Therefore, students, now we understand what type of work we are talking. Students, what is the scientific concept of the work? I am talking of the scientific concept of work is that work is said to be done only when applied force produces motion. So our definition of work is very clear that force has to be applied. There has to be a force, student, and there has to be displacement or distance to which the body will move. Two important things. This is what I call as the conditions of the work. Scientifically speaking, I am defining there are two conditions which has to be there in order to do the work. Work, I am saying W is the work, student. So this work, one thing is very clear. It depends on the force applied and displacement produced. That means, supposing I have a box here, student. Supposing I am putting a box here, student. What is that thing? It moves from, it is moving, students, when I apply a force. When I apply a force to this, it moves. And supposing, students, this moves to a distance, this moves to a distance, student. Which direction it is moving? This direction. Force is applied and the object is moving. Now what has happened, student? I can say that F is the force applied and student S is the displacement or the distance to which the object moves. Then the work will be equal to, work is equal to, student, force into displacement. Work is equal to force into displacement. Tell me, any doubt? Any doubt here, students? Therefore, work done by a force acting on an object is equal to magnitude of the force multiplied by the distance moved in the direction of the force. What I can say? Can I proceed further? You have noted down everything? Then I will proceed further, students. Okay. So, students, okay, good. Okay, thank you. Your interaction is very important, very good for me because it provides me energy, motivation to think and give you better and better examples so that students we can learn the science in a better way. All right, students, you are so good. You are so good. So therefore, students, we have got one important thing. There are two conditions which we are talking about work. More force you apply, the more will be the work done on the body, on the object. Yes or no? Tell me. If the magnitude of force you are saying, the magnitude of force student F. If it increases, what will happen? Then the work will be more. And you already know, we have already defined force in the previous chapters, which was given as m mass into acceleration student. We defined force. And what were the units of the force student? What were the units of the force which we used? SI unit of the force. What was the SI unit of the force student we use? Newtons. N. So the more the force applied, the more will be the work, or you are saying the work is directly proportional to the force which has been applied. And then how much distance the body moved? What is the displacement? Then work is also proportional to S, the displacement, the displacement of the body. The body is here, it moves from point A to point B. This object moves from point A to point B, students. And you are saying this displacement is S. S is the distance moved. The more the distance moved, the more is the work done on the body. So we can combine the two, and what we get? What is the, you are saying W is proportional to F into S, or if I say some constant is there, in this case, if K is equal to 1, then what will happen? Work is equal to force into distance, student. So this is the formula we are giving. The science says that work is equal to force into distance. But you tell me, can a work be done without having any energy? Can I teach you? Can I do any work without energy? And energy, where the energy is coming, the food which I am eating gives me energy. My hand is moving. You can see. So this way, energy has to be there to do the work, and machines also do the work. Different machines are doing different type of work at your home, but you are supplying them electrical energy or providing some fuel to them. fuel for the Fuel for the machines, and fuel for my body is the food which I eat. Therefore it is clear that work is equal to force into distance, and the work is a scalar quantity. Work is a scalar quantity, student. Scalar quantity. Can you tell me what is the difference between scalar and vector quantity, students? What is the difference between scalar and vector quantities? You already know. What is a scalar quantity? It has magnitude but no direction. Here we are saying work is a scalar quantity. It has only magnitude, not the direction, students. If I say work is equal to force into distance, students, then what will happen? What are the units of the force? What are the units of the force? SI unit of force is Newton. N, what do you represent? N. S is meter. So what will be the SI units of work, students? Newton per meter, and this Newton per meter is also called joule. Joule. So we can say Newton per meter or joule, student. Therefore, the if if force is one, if you say force is, if the force, student, if the force is 1 Newton and displacement is 1 meter, then work done will be equal to 1 Newton into 1 meter. That will be 1 Newton meter will be equal to 1 joule, students, 1 joule. Therefore, 1 joule is the amount of work. 1 joule is the amount of work done when a force of 1 Newton produces a displacement of 1 meter. Is it clear? Or any doubt is there, students? Is there any doubt or clear what we are saying?
No, sir. No doubt.
Therefore, I have an object. I have an object. This is my object. I am applying a force of 1 Newton and it moves 1 meter, students. Then what is the amount of work done? 1 joule. 1 joule is the work that is done, student. So here we have got a expression for the calculation of the work which is done whenever force is applied and distance is moved by the any object, then work is done. And by multiplying the two, we can get the amount of the work done. For example, a question student. Question is a force of 15 newtons, ठीक है, acts on an object, students, in the direction of motion. The displacement is 5 centimeter, 50 centimeter. Displacement is 50 centimeter. Find the work, find the students' work done. You have 1 minute to answer the question, students. 1 minute to answer the question. What is the answer coming? What is our answer, student? Work is equal to force into the distance. How much is this? 15 newtons into how much you will multiply? What is the answer? This is centimeter. We have converted into meter, SI units. So 50 by 100 meter, students. So what is the work then? This will get cancelled by 2. So what you will get? 7.5 Newton meter or 7.5 joules. Is that right? Tell me. Correct? 7.5 joules. Is this answer correct?
Yes.
Okay, so we can calculate students work by multiplying force into the distance or the displacement. Work is a scalar quantity. Therefore, students, we can use it. Now, expressions to calculate the work. Expression for work against the gravity. What it means, student? What do you mean by work against the gravity? Here, for example, students, what I am trying to say, work against gravity. Work against gravity means what, student? We are talking of work against gravity. Supposing you have a well. This is my well, student. And there is a water inside this. Water inside this. And you are pulling a bucket. This is a bucket, student. You are pulling bucket which is filled with water. Bucket. This is my bucket. You are pulling it. What is happening? Is the work done? The question is the work done? What is the definition of the work? You said force is applied. Force is now applied in this direction. Force is being applied in this direction, students. What is happening? You are pulling this bucket filled with water, but against the gravity of the earth. The earth gravity is, this is the, where is the gravity acting? Downward, and you know value of g, the gravity acceleration due to gravity when object is coming towards the earth. I am taking it against the earth. So in such cases, what will happen? You are saying work is force into the displacement. Then in such cases, what will be the force? Force you already know is mass into acceleration, or here you say force is equal to m into g. So you have m, and what is the distance moved here? The height to which you are taking this, I can replace by h. So here the work of the gravity will become equal to mgh, students. I can apply that formula in such cases. Mgh. G is the acceleration due to gravity, h is the height through which the object moves. Another interesting thing, students, what is happening if I have an object? Supposing there is an object, student, it is moving, this is moving with a uniform velocity. It is moving with a uniform velocity. If there is it is moving with a uniform velocity, students. If there is an object, it is moving with a uniform velocity. It is moving with a uniform velocity in a particular direction. Now, what happens? I apply a retarding force. I apply a retarding force. I apply a retarding force, student, in a direction opposite to the direction of the motion. This is moving in this direction. I am applying a retarding force in opposite direction. And the angle between the two is 180 degree, students. Angle between the two is 180 degree. Object was moving in this direction, force is applied in a direction opposite to it, angle is 180 degree, student. And let the object stop after a particular displacement. After a displacement S. What happened? I applied, this is moving in this direction, uniform, I apply a retarding force opposite to it, and after, what happens after a particular distance? I'm saying this force is acting in this direction and the object moves after a particular displacement S. After some distance S, the object stops. Now in this case, what has happened? The force, what will happen, student? The work done will be by the force. Force is taken as negative. So here, what will we do? Here I will take force will be taken as negative, students, because it is applied in opposite direction. Retardation, it is a type of retardation, retarding force. This is a retarding force, students, and therefore the work will be here minus F into S. So this is example where the work will become negative because it is in the opposite direction. The work done by the force is now minus F into S. So this work is now negative. Work is negative. It has been done, but in a direction opposite, in a opposite direction. This case, the work is opposite and is negative. It is done in a negative. So you can see that what we are talking, students, about the work and what type of works we are doing, students. So work done is negative when the force acts opposite to the direction of the displacement. All we are saying, students, work done is negative. Work done is negative when force acts ठीक है, to the direction of displacement, ठीक है, to the direction of the displacement, to the opposite direction of the displacement. What I am saying, to the opposite direction of the displacement. So then in such cases, what is the happening? Work done will be what? Work done will be negative. Work done will be negative. So we can have different types of work which we are trying to explain to you. Different type of works which we are trying to explain to you, students. What I am saying, that what are the various types of work? We are saying work can be positive work, negative work, zero work. If force is applied in the same direction, as the direction of Are you able to listen to me? My sound is coming to you, students? Are you able to listen to me? Tell me.
Yes, sir.
Yes, sir.
Okay. Sometimes some network problem can be there, so be careful. I am saying when the force is applied in the same direction of the displacement, then work is positive. But if force is, if force is, student, when the force acts is in opposite direction, force is in opposite direction to the direction of displacement, to the direction of displacement, then what happens? Work will be negative. Work is negative. Work is negative. So there are two types of work. We are saying positive work and negative work. What about zero work? What do you mean by zero work? Can you give me any example of zero work? What is a zero work, student? Can you give me any example of a zero work, student? Any example of a zero work? Think about it. Think about it. Important question. Important question. Important question. Students, can you give me any example of zero type of work, students? I have said positive work, negative work. Both you understand positive and negative work. But what about zero work, students? What is a zero work? What is a zero work? You are, I said you are pushing the wall. You are pushing the wall. Is the wall moving? Then what happens? Work is equal to force
So,
into
so
distance.
like, if we are standing holding bags in our hands and if we are not moving.
That is correct answer. What we said. That is the correct. That supposing you are saying you apply force to a wall. Wall does not move. Wall does not move, students. Then what is happening? S is zero, then work is zero. No work is done because work is F into zero. So this is one example. Second, student, coolie. There's a coolie, it holds a bag on his head. This is a baggage. This bag is on the head. On the head. What is happening? Now the bag is on the head of this coolie. If he is standing, student. He is standing. No work. No work. Supposing he leaves you at the platform, still the bag is on the top of his head. He is moving. And you can see that he is moving in this direction. And the force is, this is the force is acting in this direction. Now, important point. Force is acting downward and the motion is in this direction. And this angle is 90 degree, student, 90 degree, right angles. The force is applied at right angles to the direction of the motion. Then in such cases, we say that work is given as force into S into cos theta. Is an angle. Now when it is cos 90, cos 90 is equal to 0, student. This is a mathematical way of representing it. Mathematical way I am saying, mathematical formula I am giving. Cos 90, if I put F into S into cos 90, student, cos 90 is 0. F into S into 0. What will be the value? 0 work. So when force is acting at right angles to the direction of the motion, then also, student, work done is 0. Work done is 0, students. So this is another formula which I have given you for the work. So if you are standing and holding something, similarly you have a bag, you hold it horizontally, move towards the airport, then what happens? We can say that the bag is perpendicular to the motion, the work done on the bag is zero. Work done on the bag is zero, students. Similarly, certain these are examples of the work which is equal to zero, students. What I wanted to tell you that the expression for the work done and force makes an angle with the direction of the displacement. If some angle is made with the direction of the displacement, then I can apply this formula. For example, student, if you have a bag like this is a luggage, and I am pulling it like this. Now here it makes an angle theta with this. The bag is, this is moving in this direction. Force is applied at angle theta. Force is applied angle theta. This is the direction of motion. Direction of motion. In such cases, I can give a mathematical formula. This is a mathematical formula, student. I'm not going into derivation of the formula. In higher classes, you will learn it. Mathematical formula. And you should know that when this angle is 0, cos 0 is 1. Work done is maximum when theta is 0. If theta is equal to 0, students, then cos 0 is equal to 1. And in that case, what will happen to the work? Work will be force into distance. And if theta is equal to 90 degree, cos 90 is 0. And then what will happen? If I multiply this by 0, then work will be 0. The work will become F into S into cos of 0. This is equal to this value is 0, student. If this value is 0, then what will happen? Work will be equal to 0. Or if different angles are there, then there is a value of the cos, student. There is a book in 10th class book, it is given cos theta. It can be 0 degree, 30 degree, 45 degree, or 90 degree. These values are given in the book. This value cos 0 is 1 and cos 90 is 0. So these values are given 1 by 2 and like this. So this is 1 by 2 and this is 3, something like 3 by root 3 by 2. Like these values are given in the book, students. So when they make angle with the force, student, then this is a formula mathematical which can be applied. But few things are very clear to us now. What are the things which are clear to us, students? What I told you, that there we have given expressions to calculate the work. When against the gravity, I can apply this formula, and the units of this, you know, the work units of the work are joules. Therefore, students, what I am trying to tell you, in science, students, I told you what is work. Tell me now fast in 30 seconds, what is work, students? What have you learned from this? What is work? Work is equal to force into displacement. ठीक है? So what are the conditions for work to be done? What are the conditions for work to be done, student? Tell me. A, there has to be a force. That force must be applied. Unless force is applied, no work will be done. Yes or no? Tell me. Fast. Unless force is applied, no work will be done. Second, the body must move. The body, the object, student, must move displaced. Some displacement should be there. Move means displacement should be there, S. So third, you said formula for the work is given by force into distance, student. And fourth, I said what are the units of work, students, SI units. How will you calculate? Force newtons, S meter, Newton meter square is also called joules. So these are the SI units. Whenever questions and numericals will be given, students, we have to be careful of the units or we will do mistake in the exam. Fifth point, what I said, then if work can be positive, work can be negative, and work can be zero, students. There are three possibilities. When force may be applied, but still work can be zero, as we have given you examples of the situations. And if that force is applied in a direction opposite to the direction of motion, then work is negative. For example, this object is moving in this direction, student, but there is a force which is opposing this. What is the opposing force? Tell me, which force opposes the motion of the body? There is a opposing force, student. Opposing force. Which is the opposing force which opposes the motion of the body? What is that called? Force of friction. And if this is moving in this direction, there is a force of friction which is moving in opposite direction. The force of friction is negative. Force of friction is negative, students. Therefore the work due to friction will be, the frictional work will be, the work due to friction will be negative, student, negative. So the work can be negative, work can be positive, and work can be zero. As you said, you are putting your bag on head and standing, no work is being done because you are not moving. And Kulli puts the bag on his head and moves. What happens? The force is acting at an angle perpendicular to the motion, 90 degree at the motion. Again, the result is zero work. Again, the result is zero work, which we have given the formula, students. Formula: if force is acting at 90 degree and the motion is this direction, this is the direction of motion, student, then what formula I gave you? F into S into cos theta, student. Here I said F into S into cos 90. Cos 90 is 0, students. Therefore work is equal to F into S into 0 is equal to 0. No work has been done in such cases when the force is acting at 90 degree at right angles perpendicular to the direction of the motion. So these are some of the cases in which we can find, you see, the types of work. And as I said, if you are pushing something against the gravity, just you are taking a bucket full of water from the well, student. Again, what the result is that we can use the formula of the work as mgh, because force is m into a is equal to m into g. You already know the value of g, 9.8 meter per second square. So we can apply that formula also for the work. The units again are going to the joules, which we have told. So the interesting thing is that, question to you: can any work be done? Can any work be done, students? Can be done by without applying a force? Tell me, can there be any work or done without force? Answer is no. No, it is not possible. So there has to be a force. And how will you do the work? Work will be only done if you have energy. If I don't have energy, how will I do the work, student? Whether you are moving or any object is moving, the energy has to be there. So this is important. And the units, the energy possessed by, uh, that means you are saying no work can be done if I if we don't have energy. We don't have energy, students. Even machines, how the machines are working, how the machines will do work. Washing machine, how it will do work to wash your clothes, students. It has to be given energy. It has to acquire energy. The therefore energy is also related with the work. Important point. Important point. Student, work is also related with the point. So we can try to solve some of the questions on this, students. The first topic which I wanted to discuss with you today is the work which we have told you. Uh, we have given you already some questions which are provided in the book, student. Question, he says, when do you say, when do you say work is done? When do you say, student, work is done? You have the question. Second, define 1 joule. Define 1 joule, students. 1 joule of work. What is the meaning of 1 joule? So, what do you say? Work is done. What is your answer, students? What is your answer? What is your answer? When do you say work is done, student? We have already told you the two conditions, force and displacement. Work should be done and displacement should be there. What do you mean by 1 joule of work, student? Work is equal to force into S. So when 1 Newton meter force, displacement is 1 meter, that will be equal to, student, work which will be equal to 1 joule. So 1 joule of work means when 1 Newton of force is applied and the displacement is 1 meter. 1 Newton force is applied and displacement is 1 meter. Question number 3, student, he says that a porter lifts a luggage, porter lifts a luggage of 15 kgs from ground to his head, हेड, ठीक है, 1.5 मीटर अबव द ग्राउंड, ठीक है. कैलकुलेट द वर्क डन, कैलकुलेट द वर्क डन. You have 1 minute to answer the question number 3, student. 1 minute to answer the question. Give me the answer of the question 3. I give you 1 minute. Give me the answer of question 3, student. Fast. Important questions on the topic of work. Have you got the answer, students? Anya, what is the answer coming? Vidhi, got the answer? Porter is lifting the luggage 15 kg from the ground, student. 15 kg you are lifting to what height? How much height? 1.5 meter from the ground. So when you are going from this to this point, 1.5 meter, student, 1.5 meter, then what is the work? Work is force into distance. In this case, you the force of gravity, you know, F is equal to m into g here, m into g, and s is the height, which is 1.5 meter. So what is the problem? No problem. If I take the mass is 15 kg, and g, if I assume g to be 10 meter per second square, 10 meter second inverse, and height is 1.5 meter, students. So what is the value you are getting if I multiply these? 1.5 by 10, 10 and 10 cancels, to 15 into 15, 225, student. 225 kilogram meter square s minus 2, which will mean 225 newton, uh, kilogram meter second inverse newton per meter, which is equal to 225 of joules. So this is the answer, students, which we are getting. So we can now understand, I hope this time it is clear to a student what is work in science, how do we calculate work, force into displacement, and what are the different types of work which we will experience, what are the SI units of work. It's a scalar quantity, and sometimes you are applying a force but no work is done. Why? Because we have told you, if displacement is zero, or if the force is acting perpendicular to the direction of the motion of the object, then also no work is done, students. And if it is against the gravity, then the formula will be mgh for the work. Okay, then, students, bye bye. I will meet you in my next class for another session, which will be on energy. I hope you are doing good, and you are already doing, performance is very good in all the exams and tests which we are giving. Thank you very much. We'll see you in the next lecture. Okay. Okay. Bye bye.
Thank you, sir.
Okay, then we'll meet you in the next class.